Uh, I just gave you the explanation of what we are supposed to learn in mechanics, and we simply came to this conclusion that anything which requires or which is in motion, that thing, the study of that thing comes under mechanics. It can be moving in straight line, it can be found moving in plane, just like a ball, or it can be moving like a helicopter as well, three-dimensional motion. So there are a lot of possibilities. So we'll try to understand these motions. Because in order to understand these motions, we need certain knowledge, you can say, understanding of these physical quantities, like dimensions, distance, speed, velocity, what is acceleration, retardation, as well as that how they all vary with respect to time only. So we started with understanding these terms first. I just gave you a quick explanation in this unit, which is known as kinematics, is basically study of motion of an object without actually knowing its cause. Like why is it going on? We don't care about it. We simply try to understand it. How is it moving? Although the cause of acceleration is generally force. When an object experiences some force, then only it came into motion. So the cause is actually the force, and we'll discuss about the force in dynamics equation, dynamics unit. Forces in dynamics. So that is already there in this course. So we'll talk about that. But here now we'll try to understand motion. So we started with distance and displacement, like understanding what is distance and what is displacement. I just gave you this idea that distance is something which is the total path length, like that distance which the object has actually moved, whereas displacement is the shortest path length. In most cases, mostly the quantities with which we are dealing, they are vectors. So understanding vectors are very important. And the second type of vector we should know is displacement vector. So basically, you can assume that there is a point P. A particle moves from point P to point Q like this. With respect to the origin, these 2 points must have some coordinates. Let's say x1, comma y1, comma z1. Let's say x2, comma y2, comma z2. So in order to define its position, or you can say in order to define its displacement vector, we need to draw its position vector, like how it should look. Position vector must be drawn from origin to the point directly like this. You should draw it exactly head to tail. So basically, you are drawing an arrowhead. So vector is basically represented by arrow. We did its representation by arrowhead. So this part is basically called head, and this is called tail. Understanding this fact, this part of vector is also important because when we are finding, or you can say when we are finding the resultant of two vectors, we have to first arrange them according to their tail and head. So direction matters. So here I can say that this must be OP vector and this must be OQ vector. So if these are the two vectors, then what should be this point PQ and point P OP can be written with? I can write it as PQ vector, let's say. So here comes a very small, or you can say a very important law, which is used to add vectors. Like how to add these three vectors, like these three different directions. One is heading towards P, another is heading towards Q, and another or from origin it is also heading towards Q. So Q basically the final position. That's why again how to add these two things, how to add these three vectors in mathematics, or you can say in mathematical form, we have a law, and that is something called triangle law of vector addition.
Okay.
So using this law, we basically add vectors, and it is very important because if you understand the essence, or you can say the feel of this law, it is very easier to go. It is going to be very easy to deal with vectors. So I'll try to make you understand it as best as possible. Just try to assume whatever I'm saying. So suppose there are three vectors. So into before going into it, there are a few more things that we need to know about vectors. So vectors are basically representing the initial and final position, where the initial position is represented by this tail part and the final position is basically represented by head part. Or if something, if we're dealing with some field sort of thing, in that case, this arrowhead will be drawn that from where that field starts, it will be represented by tail, and this head will be representing that part where that field terminates. So it is basically representing the direction as well. So in case of force also, in which direction the force is acting, we will draw using this arrowhead only. So that is very important. So vectors are the arrowheads which can be drawn in plane anywhere. Apart from this, suppose there are three vectors in the system. They all are like this. And I wanted to draw all of them at the same point. If I do that, I can do, but I have to keep the directions of these vectors as it was before. Basically, the direction should not change, but you can move these vectors parallelly in the plane, something like that. So whatever angle it is making with the y-axis, x-axis, we can simply find it out. And that will ultimately tell us that these vectors are originating from a common point. Like this is the way to solve these vectors. So we can do that. Although if I want to change their shape once again, I can do like how I am suggesting it. Suppose the C vector, I just drew it here. This A vector, I draw here. Mm, there are a lot of possibilities. We'll talk about those things. Let us just try to understand what triangle law is. Like this much information is enough to understand it. So I'm assuming that I have two vectors, vector A and vector B. The triangle law will help me to add these two vectors. So how I am actually supposed to represent their directions. So we simply learn we represent their directions by angle. Like this B vector is acting above x-axis at theta degrees. I can say that. Whereas this A vector is parallel to positive x-axis or positive x direction. That is what I can say. If I want to add them, the first step I will do is I'll bring them in this order only. Again, I'll join them only in this order. Tail to head, tail to head. So A is like that. It is tail of A, it is head of A. If I bring B closer to it, I'll bring in this order so that I'll join them head to tail. So it becomes a sequence basically. Tail, head, tail, head. Like this is how you can rearrange them. Now the question is how to calculate the third vector, the resultant. Resultant must be given by the third side of the triangle, joining from the first point to the final in opposite sense. Opposite sense means tail, head, tail, head, but here it should join by head from this part. It is of resultant and this is of tail of resultant. Resultant means the sum, basically the net effect of these two vectors in the space. That is what resultant is. What is the net effect? Like you can imagine this thing by simply understanding. If you hit a box from two different sides, uh, like like you and your friend hits the box from two different sides at the same time. So how that box will move, the net effect, what should be the resultant? That is what you have to think of. So here that net effect would be drawn or given by in this way. Now let us try to apply the same logic in writing this or drawing this. So head, tail, head, and this is breaking the cycle. So this must be resultant. Did you got it what I said?
Yeah.
Just observe it properly. So vectorially, when we are writing these equations, so this R resultant, it is equals to sum of A and B, but in vector form. This resultant is basically written in vector form, and vectors have two components, magnitude and direction. So magnitude is calculated by a different way by solving this whole diagram, and direction is basically given by the angle. So what angle this resultant is making with the A vector, that is what we are calculating. Because whenever we have to explain the direction, we'll just refer something. Like if you want to explain where this particular shop is to your friend, you're like giving some references. Like after this, you can check it out. Second left, first right, whatever it is. You can say referring to a certain point. Here in 3D plane, we don't have such things, so we just use angles to describe it. Like this is a whole 3D imaginary world where you are trying to put those vectors which are actually taking place in real life. You just have to think in that way. Again, these are not difficult part. It becomes difficult to those who are not able to apply it properly or beautifully. If you are able to do that, if you are able to see these vectors in your real life, the subject becomes very easy because that is what you have to do later on as well. So as I told you, you just have to observe this. So this follows the cycle, and if I want to write it, I should have write OQ vector must be equals to OP vector plus PQ vector, like that. So this
Okay.
is very important, although I'm not going to tell you the exact need of this right now because we don't need that. But yes, this will come in upcoming classes back, and there if you already know this part, that yes, I should supposed to add these vectors this way only because of this rule. Let us solve this thing and find out the magnitude. So that is another part about vectors. Although we know that, but let's discuss it. Apart from this, vector which is supposed to be represented by, let's say, A, it must have two things. If I want to write those two things mathematically, I would say that this vector has magnitude as well as some direction. So the magnitude of a vector is basically represented by mathematically by modulus of that vector. And to calculate modulus of that vector, I guess you should know because you did calculus previously.
The square root. It's like using the Pythagorean theorem to find the hypotenuse, right?
Yeah, kind of. And this is
Like
representing the direction. Yeah, you're saying right. So you know you have an idea, and that's fine. So direction and modulus is basically representing the vector's magnitude, and a cap is representing the direction. This is important. So if I have to write magnitude equation for any two vectors, like after adding them, so how am I supposed to write that equation? Also, you need to keep that vector resolution in mind that how we resolve two vectors, and I'm taking this forward. I'm taking this diagram forward. So now, as I want to understand how to calculate the magnitude, I'll properly refer a horizontal line because this line will give me a clear idea that how these vectors are acting. Angle is important again, so reference is important. So suppose this is my first vector. This is vector A, I guess, and I have another vector, vector B in plane, which was placed randomly over there previously, but I just placed it here in the direction like that. Also, these two vectors has certain angle between them, and that angle is theta. I'm assuming it as theta, and I'm writing this vector as vector b. As we know, if we have to calculate the sum of these two vectors, we have to add them. So how to add them? In order to add them, we just draw a vector breaking this effect, or you can say breaking this, basically breaking this rule, this from tail to head and then tail to head. We'll draw a vector opposite in sense. This will give me the resultant, and that resultant is equals to a plus b vector. But I have to calculate the magnitude. How to do that? In order to do that, we'll assume that this is point O, this is point P, again assume it as Q, and this has R. So this becomes a right angled triangle.
yeah.
In this right angled triangle, I will simply say OQR, in a right angled triangle OQR. OR square must be equals to. OQ square plus RQ square.
Yeah.
This OR is basically representing the resultant's magnitude. So this is how I am supposed to represent it. R vector, modulus, and then square. OQ square is represented, or I can represent it as OP plus PQ. But this time it should be whole square. Whereas RQ remains RQ. Now the question is, what can I write in place of PQ and RQ? I know this is A, but what about this PQ? This PQ can be the component of this vector B only. What is that component? That component was B cos theta. Similarly, a perpendicular component is also there, which is B sine theta.
Yeah.
So I can write B cos theta and B sine theta here. Now again, the vector resolution part, which we saw previously, that is you need to refer once. If this was a vector 10, I have to write that 10 vector in x-axis. It came out to be 10 cos theta, whereas in y-axis it was 10 sine theta. So I can draw this y here as well, because vectors can be bring in plane anywhere upside down without any problem. Like you can do that to solve them. So in place of these things, let me write their values now. So it is going to be OP as A vector magnitude plus PQ, which is B cos theta, this whole square, and RQ is B sine theta whole square. Now I'm writing them really quickly. I'm solving them quickly now. So this A plus B cos theta will become A square, A plus B whole square. So I have to solve them. I have to solve using that relation. So it will become A square plus B square cos square theta plus 2AB cos theta. And this will become B square sine square theta. Again, we are writing magnitude. So we need to actually write this mod. But writing mod everywhere in the equation makes it a bit lengthy. So for your reference, you can just consider it in your mind that you're solving for magnitude. So this is not vector, this is the magnitude. Like what are the actual value of this b? If it is 4, so we'll write 4 here. This is what I mean. So that is what magnitude is. We can solve them further, and this will become a square plus b square. Now let me just take out b square common from b square cos square theta plus b square sin square theta plus 2ab cos theta. So here you can see that cos square theta plus sin square theta is 1. So the resultant comes out to be a square plus b square plus 2ab cos theta, like that. This is the resultant. This is the magnitude of the resultant. We are going to use this relation a lot, like a lot. In 90%, or you can say where you are dealing with vectors, you are using these relations to add them. You have no other choice. This is magnitude of resultant vector. Now let me just give you a little bit more idea. Although we are not carry forwarding it, I'll be just trying to give you an idea. So think it from that point of view that how we are supposed to use it. Suppose there is an object. Again, it is not related to kinematics. And there are two forces acting on that object. One is 5 newtons, let's say. Or I should take it as 3 newtons acting in this way, and 4 newtons are acting in this direction. What is the direction of net force? Like what is the direction where the net force is acting? Must be between them, right? This is the resultant. How to add that resultant? How to find that resultant's magnitude? We'll simply use a square plus b square. A is 4, so 4 square plus 3 square plus 2 times 4 times 3, and the angle between them. If we just look at these vectors, the angle between them is supposed to be 90. That must be cos 90. When you solve it, you'll get 16 plus 9 whole under root, which is 5, because cos 90 is 0. So the resultant force with which this object will move is going to be 5 newtons, and it is going to move in this direction. If I want to represent the same thing on 3D plane, it is going to be a little complicated, but let me try. Like there's a box kept here, and you this just moved this box like by 3 newtons force in this direction and 4 newtons force in this direction. So as a result, the resultant motion is observed in this direction, and the net effect is 5 newtons. So it must be at certain angle. In order to define its direction properly, we'll write that angle. I hope this makes sense.
Yeah.
So understanding this is important because we are going to deal with vectors a lot. Or I should say that vectors are basically something which you gives more idea about how the application part is going on. So let us just get back to our topics. So we started with distance and displacement. Then we learned about speed, the calculated average speed, but we didn't talk about velocity. So let's talk about velocity because velocity can be of many types. Understanding it from vector's point of view, so we'll try to understand it. So first, we can calculate velocity for a regular uniform motion. For uniform motion, velocity is simply calculated by displacement over time, like how much displacement a particle does, and that too in what time. So very simple example, if an object moves 5 meters, or I should write 6 meters or 60 meters in this direction, and then 80 meters took left. Again, whenever you are looking at anything, just look at from the dimensions point of view. It will be a little more helpful. So yeah, you have to consider the three dimensions. Like so, try to visualize it. So suppose this is how the particle moves. So displacement in that case must be this, and displacement's resultant is calculated by what? A square plus b square plus 2ab cos theta. Like this is the most important formula that you're going to use for the rest of the session. So if it is very much good if you use it, or you can say if you just uh, pour it into your veins. Cos theta in this case also is going to be 90 degree. As cos is going to be 90, so a square plus b square, that is 60 square plus 880 square is going to be 1000, that 10 square, 100 square. So I can write it directly as 100 meters. So displacement must be 100 meters in terms of magnitude. So here I can write the display lost in this case is going to be 100 meters. And let me assume that doing that motion, the object took, let's say, 5 minutes. So we have to write the time in seconds always because these are the fundamental quantities. Displacement is basically length. You are measuring the length between 2 points. So that length is a fundamental thing. And that fundamental thing is measured in meters in, you can say, physics. In physics, we follow MKS system, and that MKS system is what allow us to use seconds as a time unit. So we have to put it into seconds. So 5 times 60 becomes 300. 300 meters per second is the speed, is the velocity. And again, we have to write the direction. We can also write same thing in vector form, like how? Let me write the displacement thing first. So displacement, I'm assuming it as r. So r can be written as 60 I cap plus 80 j cap. This is how the resultant can be written in form of vector. If you have to find the magnitude, you can simply use that same thing, 60 square plus 80 square. Because the moment you have written it in I and j form, like representing the direction, now it is clear that angle must be 90 degree. So no need to write this AB cos theta anymore. Again, this will become habit soon once you are using it as much as it is required. So I hope this part is also clear. Let me give you a simple question now. You have to think of it, or you have to think of all those things which we have learned so far. And if you're able to answer it, it means you make most of it. So basically, the question is basically there's a person which goes 30 kilometers towards east. So I'm assuming the directions here. Try to understand it. So this time north, south, east, west. So here a person goes 30 kilometers east. Let me make it easy for you. 30 kilometers east, and then he walks 50 kilometers west. So 50 kilometers west, it means must move this way. 50 kilometers. Then question says he goes 10 kilometers north. So north, something like that. Question is find average speed and average velocity. So take your time, think of it. And the whole journey, which took 15 hours, he must be walking. No.
So
So try it out.
how do I know the time that's taken in each part of the journey?
That is something which you don't know. You know the total time. You have to think of it in this way.
Okay. Is there a constant speed, or we don't know the speed, anything about the speed at all?
We know the total time only. We know the individual distances. We know in which direction the object has moved. That's all. You have to find average speed and average velocity. So think of it. It's possible. You don't need the speed and all. The average speed in this case would be total
96.
distance, that is 90 over 15, which is kilometers per hour. But what about average speed? Sorry, average velocity. What about average velocity? Now we are supposed to find out total displacement. So how can you find out total displacement?
It's from the starting point to the end point.
Yeah. So
The
this
displacement would be square root of 500, right?
500 square root of 500.
Yeah. Because from the starting point to the end point, the x component is 20 kilometers and the y component is 10 kilometers, right? So then the displacement would be square root of 10 squared plus 20 squared.
Right. So you got the answer then. So 500 square
Square
root
root
of
of
500. So it
divided
can
by,
be written as 10 root 5.
yeah.
That is
So it's
2
two,
root 5 by 3
yeah.
kilometers per hour. That's all. This is what you have to do. Let
Okay.
me give you one more similar question. Let's try to answer it this time. So basically, the question says a person goes 20 kilometers north and then 20 kilometers east and then 20 kilometers northeast. Find the average speed and average velocity. Same question.
And
And
how
the total distance, total time it took is 6 hours.
6 hours. So then the average speed should be 10 kilometers per hour. And then distance.
Can I write
So
it like this?
yeah, that's what I got for average velocity.
Yeah. So in order to find out the displacement, initial position is this, final position is this. This must be the vector.
Yeah.
So this is 20 kilometers per hour only. We have to find this one. So this one can be calculated using same way by using the resultant thing. A square plus b square plus 2ab cos theta. Cos 90 is going to be 0. 20 plus 20, it is going to be uh, 20 root 2 kilometers. You have to square it also. So a square plus b square whole under root as well. So keep that in mind. So 20 root 2 kilometers plus this 20. This is what displacement is. You can simply take out 20 common from this by 6. You can simplify it 10 over 3 and root 2 plus 1. If you want to solve it, you can. If you don't, it's fine. Again, understanding the requirement is important. That how much did you understand the concept? That is what which is important. So, what would you say? How much you got all of these things? Like what we have learned so far?
I understand how like the velocity and speed, how to find them based on a diagram. So speed is just like then all the velocity. This is the entire distance divided by time, and then velocity is displacement over time. That's the difference for average. And then how to find the displacement when there's a right angle involved. When like in this example, there was one north and then east. So then finding the displacement between those two.
Correct. So, this kind of motion is basically something we call bookish motion, because these kind of things are generally exist in book. In real life, the motion is like very uncertain, or you can say there is a lot of non-uniform motion. So whenever there is a non-uniform motion, let's try to understand it. Whenever there is a non-uniform motion, there must be some acceleration. There must be some acceleration. As particle accelerates, the motion changes, like the distance covered per unit time is changing. So that acceleration plays a major role. It is also a vector quantity. Keep that in mind. Whenever we are learning it from the vector's point of view, they are going to be important. But here we'll generally look at into its magnitude side. So acceleration is something which actually increases the speed of a particle already moving with some initial speed in some short period of time, if it is there. So the thing is, if a particle is experiencing any acceleration, the motion is not going to be uniform, it is going to be non-uniform motion. And for non-uniform motion, equation of position, like equation of how position is changing with respect to time. So representing equation representing this position with respect to time. Like how can we represent them? We can represent them as x as a function of time, like position as a function of time. So it can be written as 2x square, or I should write it as 2t cube. So 2t cube plus 3t square plus 4t plus 5. So this can be an equation which is representing position of a particle and how it is changing with respect to time. Like you can see that how position is changing. In such cases, like these kind of motion are represented by very small particles, microscopic particles in reality, although it is there. Similarly, equation of position as a function of time can also be represented as 2t square plus 4t plus 6. This equation can also be possible. Similarly, we can also witness x 4t plus 5. So it doesn't depend upon that the position, or you can say the time as a function of what power of the time the equation is there. Every equation is possible. Or it can also be represented as by simple one thing, t. It can also be the equation of position of a particle with respect to time. All these equations are there simply representing, simply justifying this fact that there must be some acceleration, either positive acceleration or either negative acceleration, which is also known as retardation. So you can understand acceleration in simply this way. Like whenever we talk about what's the pickup of this particular car or something, that pickup, or you can say that acceleration, justify this that how fast it can go in no time. So some supercars has like within 3-4 seconds they achieve 100 kilometers per hour of speed. So that's much. That's too much. So that is what acceleration is, and that much power those cars engine has that they can provide such acceleration in no time. So because that kind of energy which is required to give them that kind of acceleration is not easy for every engine to produce. So that's why they are called supercars. Like there's a lot of logic in everything. Some of you might know, some of you might not. But yes, as we go ahead in this particular course, you'll find out that you'll ultimately learn so many things about the surroundings, like nature. So let me just introduce you this with one thing that I wanted to discuss last in this class is about instantaneous quantities. So far we have discussed like distance, displacement, speed, velocity, average speed, average velocity. But there is another kind of velocity. Like because of the nature of this non-uniformity which is there because of acceleration, which we can actually represent using these equations. Like these are the equations which can represent the position with respect to time, like how fast it is changing, or we can plot it in graph, in XT graph. In such cases, we can write another sort of velocity, which is called instantaneous velocity. Like suppose a particle move for 10 seconds. Every second it has a different velocity because it is keep on accelerating. It is keep on accelerating. That's why every second has a different velocity. I'm taking this 10 second time stamp. So for me to understand that what is its velocity at exactly 8th second of its journey, in that case, the instantaneous velocity came into the picture. Velocity at an instance. At an instance. It can be a moment as well. It can be a very small moment. How to write it? How to introduce it with the given thing? Because if you just observe these equations, just think about these equations. If you have done calculus, you must have a lot of idea about these equations. Like what each equation is representing, what each equation is telling you, what kind of, you can say, shape they're going to give us on a graph paper. If it is
Oh,
t raised to the power 1 only, like in these two cases, it is going to be what kind of equation?
linear.
Linear, a straight line in general. If it is square, it's going to be, if it is quadratic in nature, it is going to be parabolic. You
Yes.
know that. And again, if it is going to be cubic polynomial, like the variable raised to the power 3, it can be elliptical, it can be some other possibilities are also there. So it depends upon the equation, like how we can transform it. So every equation just tell us some path, because equations do tell us path, like how particle is moving. If we are able to plot it, we are going to get the path, right? That how the object has moved. So from the same equation, we can calculate distance as well as we can calculate speed and velocity both from the same equation. So for calculating instantaneous velocity, we simply write that instantaneous velocity is something where time tends to zero, because we are talking about a very small fraction of change. So V instantaneous can be written as limit delta t tends to 0 delta x over delta t. So that is something you have must seen in calculus. Just say yes. Like you have seen these equations, right? You have learned from these equations. You have solved these equations.
Yeah.
In
Just the
limits,
different position.
yeah, in limits it's there. But here I'll try to make you understand that what exactly the means of this limit delta t tends to 0 is. Because let us try to understand. We need to understand the instance means. Just think of it, you're making a video graph from your phone. First you set 30 fps, then you set 60, then you set 90, then 120 fps, let's say. This is how you set the quality of each video. So this fps thing is very easy to make you understand that instance part. 30 fps means 30 frames per second, like the camera is capturing 30 frames and playing it in 1 second during that 1 second. Similarly, 60 fps, like 60 frames per second. So movement in this 30 fps is very, like, out of there are only 30 movements you can say in that 1 second. Just making it to hell, you can say, as small as possible, infinitely small. For that infinite small, like the change in time, like for example, if I'm trying to get the time difference of about, like, from 0.00001 to 0.00001 2. So again, this one is going to be small, but that change is very, very less. That's why we can write delta 2 tends to 0. But here in real life, in reality, instantaneous speed is something which is shown by odometer in the vehicle. You must know that, right? So whatever you are looking at that point, it is giving you the instantaneous velocity. The direction in which your vehicle is going is giving you the direction of that velocity, and the speedometer shows what is the magnitude of that velocity. And that is speedometer. Odometer gives you the distance covered. So I hope you understood that. This thing is also written in this way. We can simply write it in this way, that v is nothing but dx by dt, or the instantaneous velocity can be defined as rate of change of position, like how the particle's position is changing with respect to time. So let me assume one thing. Let me just assume that the position of a particle is 4t square plus 3t plus 6. Now I just wanted to find the velocity equation. So velocity must be dx by dt. It means you just have to differentiate it with respect to what? Time. So tell me the differentiation part. You know it.
V equals 8t plus 3.
Yeah, correct. So you have basically applied a chain rule, and that is the most simple and important rule for derivation point of view, for derivative point of view. So this is what velocity is. And if you want to find out instantaneous velocity, let's say I want to find out velocity at t is equals to 5 seconds. So velocity must be 8 times 5 plus 3, which is going to be 40 plus 3, which is 43 meters per second. So this is the velocity at t is equals to 5 seconds. This is something we can call instantaneous velocity. So there are a lot of questions associated with this instantaneous velocity part. And again, a lot difficult questions are there.